And we had been very successful, but when Jim came and the RERC opened at UAB, it opened our eyes to opportunities with to target novel exercise and recreational technologies. And so we have begun to work in a variety of projects, and I'll talk about a few of these. The FES, a functional electrical stimulation rowing machine, and we worked with Scott Bickle and one of his students. A para-percussion device, which Joe Moore, raise your hand, Joe, is the student responsible for developing this thing to the state where it is now. And God bless him, he stayed up till 3:30 last night trying to work out the bugs in the box and didn't quite make it. So he's going to give you a discussion when you go around back and talk about this device. And I have a video to show you in a little while as well. But it also opened us up to a brand new area for me, which is this area of virtual environment and body tracking and adaptive gaming controllers, which is really exciting. You saw the work that Lee Maratti's group and Sam Misko are working on. Really exciting stuff, as well as monitoring weight and energy expenditure. So, as I said, this is interdisciplinary, and here's the collaboration, and it's a beautiful one. We have engineering, we involve ourselves with RecTech, we work with School of Health Professions, with Rehab Science, and Scott Bickle's group, Center for Exercise Medicine, Marcus Baumann, and then again, this collaboration with business that helps us look towards that end prize of commercialization. And then in the center, you know, is the heart and soul of it all, which is the Lakeshore, UAB Lakeshore Research Collaborative. And again, the Lakeshore Foundation is such a wonderful facility because it allows us a place to try out these devices, to see how well they work, to get customer feedback, get client feedback, people with disabilities. And so we can go back and iterate. You know, we get that information and it allows us to go back and improve on these devices. So in my experience, this has been wonderful, and we're really, really happy with the things that we've done. So I want to just highlight a couple of the examples that we have, and some of these are over in the display area that you can come see. I invite you to come check them out. This is, we call it the wheelchair scale. It's actually a weighing device, an affordable weighing device for people in wheelchairs and bariatric patients as well. And what we learned through our collaboration is that there is a real need for devices that allow people in wheelchairs to weigh themselves. And for example, when we first began interacting with Lakeshore, they had a scale, and as I understand it, it was something like a $1,400 scale. And no offense to Lakeshore, but the people that we talked to didn't like it. They didn't feel safe on it, they didn't feel comfortable on it. And so we used that information to help guide our students to develop an affordable wheelchair scale. And this began as a senior design project. And again, for those of you who don't know engineering education, the fourth year of education, your senior year, you have a year-long capstone design project. And in our department in biomedical engineering, you develop a prototype for a particular device, and then you also, working with business students, you work towards a marketable design as well. So in the capstone course, a pilot device was developed, and then one of the students, a stellar student, Brandon Sherrod, who's not here today, he's now in med school, he stayed on for the summer to develop the what we call the Mach 2 device, where he actually was able to clean up and streamline the scale, add the ability to transmit the weighing information through Bluetooth to your cell phone, and I'll be happy to demonstrate that when we go to the other room. He wrote a manuscript that we submitted to Assistive Technology, which involved a clinical study done at Lakeshore, tested on users. And so this is an amazing student. These are examples of the kinds of students we get at UAB. We love them. But this was an example of a project that started in the capstone and has now moved on. And so I have a Master of Engineering in Design and Commercialization, and the whole purpose of this Master of Engineering is to capture those students who don't want to go to med school, they don't want to go to grad school, they want to get a job, they want to work in industry, they may want to start their own business, they want to work in the world of commercialization. And so we created a master's program as a year-long program where these students can come in and work towards commercialization of a device. And so one of the devices that they've picked up on is the Mach 2 design. And here's images of the picture. That's Brandon on the left there. And then some of the other students in the Master of Engineering. A very hands-on program. They learn all about machining, manufacturing, use of Arduinos, printed circuit boards, all the rest, to train our engineers how to make stuff. These guys are making stuff. They're actually in the process of finishing up 10 scales, 10 of these Mach 2 scales, to be used in NIH-sponsored research. So again, we get back to this collaborative. So Brooks Wingo, who's not here, another collaborator in the UAB Lakeshore Research Collaborative, is taking our scales to do her 5-year study of weight management among wheelchair users with spinal cord injuries. So we're letting her take these things, apply them to her research, which is exciting enough, but what's also beautiful then is we get to sort of take what we call a lean startup approach, where we've got these 10 scales going out, and now we can get customer feedback to see what else needs to be done to this scale to make it affordable for the masses. Right? So we're real excited about this. And this has been a project that's now in about its 3rd year of development. And again, it's over next door when you get a chance. The parapercussion device, this is another one that we're real happy about. This was the idea that drumming is exercise. I'm a drummer, Joe's a drummer. For some reason, our lab attracts drummers. And so I know when I play a gig, you know, by the end of the time, I'm sweating, I sweat off 20 pounds. So the thought came to us, let's see if we can make an exercise device that has drumming involved. Jim came to me with this image of, you know, opening the Paralympics with a bunch of kids, you know, wheelchairs with flames shooting out and playing lit up drums and all kinds of stuff. And wouldn't that be cool? So we started on this process of developing this parapercussion design. The woman on the left was part of the original senior design team that prototyped the device, but it wasn't until Joe, who's only a sophomore in electrical engineering, came into my lab, took over this device, scrapped what our BME seniors did, and started over and built this thing that is a complete gem. And I wish so badly that it was all working the way we wanted it to. In addition to developing the parapercussion, I'll show you a movie in just a second of how it works, he also began working with a client at Lakeshore who has a visual impairment. And the idea was to create a haptic headband that has vibrating motors in it that tell you which drum to hit to coordinate a learning process or to play along with, say, like a Rock Band video game. So really cool stuff. And I'll just show you the video. I hope it plays. And this is, I'll let it speak for itself. To get more exercise. And here's a learning module where it actually teaches you to play the drums in a particular order of things. This light's telling you did it right. Tells you how to play it correctly. Alright, so kudos to Joe for all your awesome work. This is really amazing. And all of what you saw with the lights, for somebody who is visually impaired, the haptic headband does the vibrations to tell you which drums to move as well. So this is a device that will have multi-use. Again, I mentioned in addition to undergraduate research, we are also working in the realm of graduate projects. So this was an example project. The gentleman on the left is Sean Poole. He began this work as a Master of Science. It's been picked up by John Hoyle, who's in the back over there, who's working with Lloyd Cooper to connect up this work with the Avid device. So what Sean was tasked to do was develop the interface to work with Connect, to use body tracking to navigate a virtual environment. And so the ideas of this, being able to navigate a virtual environment using your arms and or voice commands, was part of his study. And again, this work has now led to a publication which soon should appear in Assistive Technology, if it's not out already. Lastly then, again, I mentioned we were working with Scott Bickle. Here's another example where Scott had a project with a functional FES rower. And there were some issues with the machine, and he came to us hooked up with Sean Poole. Again, Sean being an electrical wizard, managed to hook up the system to allow them to do the bidirectional electrical stimulation, which helped Susan, who was the PhD student, complete her work, complete this device, and use the device in a clinical study that led to publication. Last but not least, something that we're real excited about as well is we have introduced a new interdisciplinary course. We have created a course called Quantitative Biomechanics and Injury Rehabilitation, and it is the first in the history of UABE cross-listed course between the School of Engineering and the School of Health Professions. And what this has allowed us to do is we've got students from rehab science, from occupational therapy, from a variety of sources within School of Health Professions to get in the classroom with engineering students and take on these topics, learn to understand biomechanics of injury and rehabilitation from both sides of perspective, right? And so it's been really interesting and fascinating to watch these students work together because the engineers, they think they know everything in this one area, and then they are opened up to a whole world that they didn't know anything about. The rehab students then have to take on the engineering task, which is always fun as well. So it's underway right now. This is the last week, and results are pending. But so far, so good. We'll find out when we get those student surveys, right? So in conclusion, we've created a range of opportunities for training of engineers to empower people with disabilities to exercise. We feature interdisciplinary teams. The goal, the long-term goal is on translation. We want to get these devices out the door and into the public's hands. The goal is optimization of health and wellness. And something that I think is sort of underemphasized but is really important is we're also exposing these students to the concept of rehabilitation engineering, which, a lot of them come through and they say, well, I didn't even know this field existed. And now we're opening these doors, we're showing them the problems, and they're turning on to it. They're getting excited by it. I've got a lot of folks that, like Joe, that just think, oh, I can do this for the rest of my life. And that's the kind of stuff that we really want to hear. As it relates to the RAMP 2.0 framework, we are active at both the research and the product development ends. I think most of our work has been primarily related to clinical or home use, and most of our activities have been person to device or person to person. But as we move into the future, I think there are areas of independent living and community activities that are now we're becoming more aware of as well. And this will be something that I will stay in continual contact with Sangi and her team to find out, where are the projects, where are the problem areas, where are the things that we can address. With regard to commercialization of devices, I'm currently working with Lloyd. We're working on an SBIR. We're hopeful that we can get that so we can move the Avid device forward, and I'm looking forward to working with Lloyd continuously on this project. And I'm disappointed that the dean of your school is not here anymore, because I was going to hit him up for this, but I've convinced our dean and my chair that this is an exciting enough area with golden opportunities that they are now willing to hire another faculty member to bring him into engineering, and hopefully we can make that be a joint appointment between engineering and health professions. So with that, thank you very much.